all. May I request everybody to come inside and take your seat. We are starting the event very shortly. Ladies and gentlemen, myself Abraham Joseph, with me my colleague Mr. Jagannathan. We are here to host this event. It is my great pleasure and honor to announce that we We are here to conduct our technical meet 2025 on challenges and opportunities in concrete construction in this prestigious IIT Research Park on this wonderful evening with all your blessings. Ladies and gentlemen, I take this opportunity to extend our warm welcome to our distinguished guest, Dr. Santhanam, Chair Professor and Head of Civil Department, IIT Chennai, and also Dr. Gettu, Chair Professor, IIT Chennai. Give them a big applause. Dear sir, we are sincerely thanking you for invitation to honor this event. It is also my great, immense pleasure to welcome our valued customers, clients, contractors, technocrats, and academics. Dear well-wishers, this event is dedicated to you. Today, we celebrate not just business relationship, but the trust and collaboration that bind us together to enrich the technical knowledge about concrete. Today, we are gathered here to exchange ideas, share knowledge, and be inspired by the brilliant minds that shape our future. Let us make this event an unforgettable experience with all your involvement, support, and active participation. We would like to ensure that safety remains top priority for all participants. I request Mr. Irfan, our safety in charge, to brief on safety in section of this premises. Mr. Irfan.
Good evening, everyone. I am Irfan Mohammed, Safety Engineer of Concrete OEM Private Limited, and I will be giving the safety briefing about emergency preparedness information for this auditorium. In the event of an emergency, if we are required to evacuate the building, there are 5 nearest exits out of this auditorium, which are the 3 doors on either side of the front row and the 2 doors at the back of the hall. There are 2 emergency exits on this floor. One is located at the back of the main elevator landing to your left exit, and the other one is located just outside the front right exit on this floor. The main staircase is located outside of to your left exit door opposite the lifting landing. The same procedure goes for the dining area on the 6th floor. When you hear the alarm, please remain alert and prepare yourself for any possible evacuations. And please leave the floor immediately by using the exits which is nearest to you. And proceed to the nearest emergency exit, which is located on the front and back of the floor, which I have mentioned earlier. After reaching the 0th floor, exit via the main entrance and gather at the assembly point to the left of D block. Do not use the elevator in case of fire or earthquakes, and do not crowd the doors. There is no smoking permitted inside the auditorium, and please put your phone.
We kindly ask everyone to stand for our state anthem. the lamp, a symbol of knowledge, wisdom, and positivity. Brightness and prosperity are the symbol of light. It is a positive force that revokes darkness and shows the right direction. I invite our distinguished guest, Dr. Santhanam, IIT Madras, Dr. Gettu, IIT Madras, our Managing Director, Mr. Tagore, Mr. Satyanarayana, our Technical Advisor, and Mr. Vairamuthu, our Financial Advisor, kindly come forward and light the lamp, marking this auspicious beginning of our event.
Please welcome, sir.
Please. Give a big applause. Please continue to give a applause. Thanks a lot, our distinguished guest, for officially inaugurating this event by lighting the lamp. As you all know that light represents knowledge and darkness represents ignorance. It is a fact that knowledge removes ignorance and light removes darkness. Ladies and gentlemen, today we are gathered here to exchange ideas, share knowledge, and be inspired by the brilliant minds that shape our future. Now, we have a presentation about our company, our new logo launch, and our journey, our few milestones, and our strength and our future plan. I request and welcome Mr. Jagan, our Senior General Manager, to give an insight about concrete OEM. Mr. Jagan.
Thank you. Thank you, Abraham. Good evening, everyone. I know it's too late, but we need to move with this very quickly. So I'll take a fast tour of it. So I request my colleague to play the video. So.
Pentagon is a symbol of strength and stability, much like our ready-mixed concrete. Its 5 sides represent the 5 key qualities of our product. The safety of the Pentagon structure of our security, much like our concrete safe foundation. Durability. Our concrete is designed to withstand the tested time, just as the Pentagon stands strong. Versatility of the Pentagon shape for various uses. Similar to our concrete, it adapts to any project efficiency, just like the Pentagon design maxims. The space. Our concrete mixes optimal performance. Finally, innovation. The Pentagon is the symbol of forward thinking. Just as we contently improve our concrete technology together. These qualities make our concrete the ideal choice for any construction projects.
So, as you have seen our logo, and I'll just brief you about the design and symbolism about our logo. Our new logo features a modern, streamlined design that embodies the principles of safety, durability, versatility, efficiency, and innovation. So, considering these 5 concepts, our logo is having a clean lines, bold topography, and vibrant colors works together to create a visually striking and memorable brand identity. When we go with symbolism, the new logo incorporates several symbolic elements that reflects our company's values and missions. Our new logo represents a renewed commitment to our customers and our mission to provide high-quality innovation solutions for the construction industry. We believe that this new logo will help to strengthen our brand identity and enhance our customers' experience with our company. Similarly, I take this moment to share strengths and capabilities of our company through a small presentation. So, if you see in the video, it is very clear our tagline is mentioned as tomorrow's innovative concrete today. So, to brief you, the concrete OEM was established in 2017, which is almost all 7 years, when many of them asked me, sir, what is OEM? So, as you all aware, we brought a concept of original equipment manufacturer, trust and worthy, from the mechanical industry to civil industry. So that is how our managing director has thought this concept of having OEM interlinked with concrete in the ready-mix industry. So that is how we got Concrete OEM Private Limited being established in 2017. So we have a leadership team of RMC experts that have been provide experienced solutions wherever it is required, and it has been blended with different professionals. Each and every process, they are having several experienced people. And our average employee age, if you see, it is just 31 years. And we have an overall experience of 200 years professionals working with us. So if you see OEM, the graph, how it has been grown, so it is a clear picture being provided on the presentation. In fact, we are just, if you see in 2020, 21, we are just 2 lakhs cubic meter. Whereas by the first, quarter of 25, we are almost all 4 lakhs, near to very 4 lakhs, and we are targeting a volume of 9 lakhs by 24, 25 end overall. 26 as well. You can say 25, 26. So we need all of your supports in order to grow all of us together. So our capabilities, as I mentioned you, all over, we are established in 3 states like Tamil Nadu, Karnataka, and Telangana, exclusively Chennai, Bangalore, and Hyderabad. Overall, we have 18 plants, 33 pumps, and a capability, own assets of 175 pumps, and a strength of employees 400 as of today, within 7 years. And we, as a capability, we concentrate on 0 accidents, assured quality, faster service, value engineering, innovation, and also moving towards ESG. So when you say our core value positions of what is the difference, what are your core values, if you define, it has been, we can say we give the faster service, and also we tailor-made, value-added engineering. So we understand the customer requirement exclusively, their specifications, then we design the required product which need to be understand. Even their structural consultant, sometimes we give the explanation to their structural consultant, what is the requirement of high cementitious content, so what is the requirement of durability. So we tailor-made the products. We give the value engineering for each and every solution. Whenever they're having a problem with the high-range buildings, placements, then we take it as our problem and we provide solutions by giving high-range pumps. In fact, you can say in Hyderabad, we are been using exclusively by understanding the problems of a contractor, and we have been procured SP3000 exclusively for them, and by understanding, because we found the difficulty what the contractor has been facing, even though mix is very good, very flowable and cohesive. So that things we understand, and some places we also started placing the concrete by ourselves as a permanent solution, because we don't want that, sir, only product is mine. You don't know how to use it, or you're unable to place it, or you're unable to consolidate it, or you're unable to compact it, and you're unable to cure it. So in certain projects, some MNC companies, we have been tied up, and we started curing as well, placing as well. So I'll come in detail later on slides. So that also we have been started, and we are also moving towards sustainability and environmental friendly mixes by using GGBS and fly ash mixes. And we are also moving towards innovation for each and every aspect of our work nature. When you go with faster service, you can say that we are almost having 30 plus customer relationship managers working 24/7 continuously, only to serve the customer, to fulfill the needs of the customer by understanding their schedules, planning properly, exclusively. They have nothing to do with the sales. They only concentrate on the planning and production. So day to day, they interact with the customers. And also 30 plus professions in each state, 90 plus GETs we have been recruited. All engineers, civil engineers are being employed in our organization. And we have more than 175 transit mixers currently. And as and when we require further, we also day-to-day basis, we take on hire whenever it is required. So when you say, as I said, we placed already 1.2 lakh cubic meters in the site with few of the contractors, where we supply, we place, and we cure it. And based on the last 3 months survey, if you see, we have got 850 plus satisfied customers, and always we target that we erect our plants within a radius of 8 kilometers so that we can serve easily to our customer needs. So we are moving, as I said, we are moving towards eco-friendly. We have almost all saved 9,554 tons of CO2 emissions, and we are targeting by 26 end almost all 1 lakh tons with the help of all of your support. So when it comes to the part of innovation, so we are, you can say almost 20,000 plus messages through the CRMs we are sending to the customer. So once we start batching any truck, you will be having a auto-figured message. What is the customer name? What is the project name? What is the grade? What is the TM number? What is the TM driver name? And also additionally we'll be having a GPS location so that the customer will be able to track the vehicles. So that is how we can, per month we are sending almost all 20,000 messages, and every transit mixes, say for example in Chennai, all the 60 transit mixes are totally equipped with the dash cameras in the front as well as in the back side. So any accidents or any theft or anything, if the driver stops on the road also, we will be knowing what minute, what he's doing, and each and everything is being captured with back and front cameras. And as I said, 100% we are GPS. And we are also integrating with our batching plant as well as pumps. Very soon we'll have our integration systems being adopted. And innovations, we are working on slump meter as well as strength prediction, and we are moving all our equipments towards EV and CNG, and all our reports we want to make digitalization. This is how we are we are moving forward with the part of innovation. And our aim, we want to expand across the India, different states. We want to spread, expand our wings, but in a professional way. And we also, recently in Hyderabad, we started giving quality assurance for one of the projects. Few of the projects being asked upon completion of the project, we started giving quality assurance as well from the bottom. Since those buildings are being totally supplied by us, so we started giving, because time to time we do the durability tests. And not only that, after completion of the project, also we are doing we are asking the structural engineer to kindly advise where we need to do. So we are sampling that, and we are also submitting the quality assurance certificates in cooperation with some certified third-party laboratories. And also, every pour, we have a keen and neat and transparent customer satisfaction data feedback. So recently, we have done a single pour of 3,800 cubic meter in a single pour of high performance concrete in Hyderabad at a single shot. Even in fact, the second pour today we started, sir. It's going on. It's also again a huge quantity. And we are capable of doing lightweight concretes through foaming agents as well as beads, okay, with the densities of 800, but average you can say 1000 kg per cubic meter. And temperature control, 3 days before, here itself, behind our auditorium, we have done one pour where the placement temperature is required 26 degrees centigrade. And we are oftenly doing in Chennai. So these are our few of Thank you very much for listening to me and having patience with me. Thank you.
Thank you, Mr. Jagan, for sharing such valuable insight. It is always inspiring to see the passion and the vision driving concrete OEM. Now, ladies and gentlemen, is the moment we all have been waiting for. It is my absolute honor to introduce our esteemed chief guest for this event. I take this opportunity to invite again Mr. Jagan to introduce our chief guest, Dr. Ravindra Gettu. Mr. Jagan.
Sir, before introducing, I want to tell one thing honestly. The two professors from last 2 years where I am getting interact, they are very, very humble, whom you are seeing on the screen, very respectable. I was in a deep problem one day. In fact, sir has called me, what is the problem? And he said, let us do the event. He encouraged me a lot. So it's a very great opportunity for me introducing him, but even though I'm not that level, so Ravindra Gettu sir, thank you very much. Manu sir, thank you very much. So, Gettu sir, he did his BTech from Government College of Technology, Coimbatore, an MS and PhD from Northwestern University, USA. He is also having a professional professional affiliations for member of Indian Concrete Institute, honorary member and fellow of RELM, and he's a president from 2018 to 2021. Few of his awards, there are actually n number of many awards, but sir has given me very, very little. So I am just reading them. Fellow of Indian National Academy of Engineering 2018, Lifetime Achievement Award at the first Interdisciplinary Symposium on Smart and Sustainable Infrastructure in Vancouver during RELIM Week 2023. The Outstanding Concrete Technologist Award of Indian Concrete Institute 2010. Then Jos Torrene Award of Spanish National Committee on Large Dams during 2002. Japan Concrete Technology, JCI OEC, Our World in Concrete and Structures Award during 2002, has co-authored more than 500 publications, in which more than 130 are peer-reviewed journal papers. So, sir, please welcome onto the dais.
Good evening. Good evening. Great to be here. I'll try to be as fast as possible so that you don't have a delayed dinner and you will have time to listen carefully to Manu Santhanam. So we'll talk about challenges and opportunities in construction. So I'll introduce our center. It's the Center of Excellence on Technologies for Low Carbon and Lean Construction. And then I'll talk about some issues with concrete construction, and specifically a little bit on plastic shrinkage cracking, fiber reinforced concrete, and sustainability assessment.
Working.
So Professor Manu Santhanam and I, can you hear me? Yeah, okay. So Professor Manu Santhanam and I come from this Center of Excellence. It is led by Professor Manu. He is also our Dean for Industrial Consultancy and Sponsored Research. So this is our group. Our newest member is Aritra Pal, who is also here. And he started off on concrete and somehow switched to computer-based vision, but he is very much in construction. So we have a very young group. I am the oldest around. Average age would be around 40. And a very dynamic group which works on construction materials, construction management, and building sciences. Our mission, or what we think we should be doing, is work towards construction which is zero carbon, that is zero environmental footprint, and zero waste. It's a tall order, but we feel that this should be the mission. And the reason is there is a lot of embodied carbon in our construction. So when you build a building, you build a bridge, there's a lot of carbon footprint which has gone into this. There is improvement in the operational part. All of you know we have LED lighting, we have fans which consume less electricity, we have air conditioning that is more efficient. But you are stuck with what you have constructed with. So that is the embodied carbon, embodied energy, embodied impacts. So we want to work on that and decrease that. On the other hand, we know that there is a lot of waste. All of us in the construction sector know that we generate a lot of waste. If we are going to build more, we are going to demolish more. So all this keeps happening. And to change it, we have to work on different aspects, not work just in the lab. We have to change policy, we have to change specifications, we have to change how contracts are written, tenders are awarded, and so on, up to taking new technology into the field. So we believe that this transformation, translation has to happen, and as a group, we would like to work on that. So our vision is to touch upon, try to influence the whole life of a project, starting from the material, the mechanical properties, this is what the designer is worried about, sustainability, which everybody should be worried about, durability, which is very, very important, look at new technology for automation and so on, durability, again, repair, how do we repair so that we can extend the life of the structure, Then if we don't have any other choice, we demolish, see if we can recycle and so on. So how can we work on different aspects? And as I said, we have a big group who is working on different aspects of this. Then we can hope that construction someday will be zero carbon, zero waste, and significantly have embodied energy and embodied carbon, which is very little. So we have been doing things. We have been doing things not only in the lab, but taking things out. We did some work on recycling of concrete, making it into aggregates and material that can be used in construction. You require a lot of energy. So we said that, can we use solar energy? In India, we have a lot of sun. So what we did is we zapped the concrete with very high heat with this plant that there is near Mount Abu, where they have these huge reflectors which just concentrates the heat. There is no conversion from heat to electricity and then we use it. And then we found out that you could separate the concrete very easily so that the aggregates can be put back in, the cement paste, hardened cement paste can also be put back in. Then we have the case of mixed construction waste. Mixed construction waste, which has plastic, which has brick and all that. And now we have people who have to pick everything out. So can we have robots? Can we have robots with vision built in that it can recognize and take out this? So this is something that we are working on. Other projects, we are working on alternative cements. Things that are not just ordinary Portland cement, but could be from agro-based waste. We have as an agriculture country a lot of waste coming from agriculture. Can we put the ash from that? So we've been doing stuff. We've used it in landfills, very low strength concrete. We've made bricks, and this has been out there for more than 2 years. So a lot of things. We have done a lot of work, as you may know, on LC3, which is limestone, calcine, clay cement. Additionally, we are looking at low-grade limestone that cement companies cannot use. So this is just lying around there. Can we use it for concrete? And Professor Manu has been leading this work. We are also looking at alternative reinforcement. We know that corrosion is a problem. Can we make structures without steel reinforcement? So we are looking at carbon, we are looking at glass reinforcement, and we are seeing how binders can also change. We are looking at new types of cement like CSAB cement, calcium sulfoaluminate, bilitic cements. So with LC3, now we are very happy that it is now a standard. Cement companies can produce and structural engineers can design with it. And we can have buildings. And we have done cases where we have taken waste clay, again that people do not want to use. We've made structures. This tetrapod has been done with the help of L&T. It's an L&T project where they are doing it. We have done also a small building, and other buildings also we have done with this to see what is the life and the durability of it. Other thing which is close to my heart is water. See, for concrete we need good water. We have always learned, we tell people you have to have good water. But we need water also for people. People have to drink. People need water to drink. And place like Chennai, you stand in line, you have people standing in line for water. So what is the right thing to do? Should we insist on good water being taken away from people and put into concrete? Or do we look at other sources? So what we said is, can we take water from sewage? Can we mine water from sewage? Partially treated water, put it into concrete, not used for drinking, but can you make concrete out of it? And we went to different places and did this. Concrete OEM allows us to do it. This was from one of your competitors. So what we did is we found that concrete made from sewage water was better than the concrete made from groundwater in those plants. Because groundwater is brackish, groundwater has dissolved solids and so on, and partially treated water was even giving better results. And I wish one day there'll be a government order which prohibits us from using groundwater and fresh water for concrete and other industrial applications and forces us to use sewage water or water that is coming from sewage and treat it. So these are some of the things that we have been doing. But let us talk about what is the process of doing something differently. So in our center, we are doing a lot of things with new materials, innovation, and so on. And there are a lot of challenges. All of you will appreciate the challenges. And one of the big things which is different between our sector and everything else is the fact that we have multiple stakeholders. You have heard from concrete OEM. They are a stakeholder. They are giving good concrete. But somebody has to use it, somebody has to specify it, and somebody has to live in it. So concrete and cement, when you change things, there are different stakeholders, different players which come into the market or come in touch with the concrete and use the concrete. All of these people have to be convinced. So when you have a new concrete, for example, say when we had this in try to introduce LC3 in the market, the constructor, the contractor, what do they worry about? They worry about workability. They have to place the concrete well. They are worried about superplasticizer dosage. They are worried about plastic shrinkage. So this is their concern. The structural designer has a different set of concerns. They are talking about strength, stiffness, creep, and shrinkage. The user is worried about durability. How long will my bridge last? They don't really care whether you use M30 concrete with LC3 or OPC. I want my house to last a long time. I want my bridge to last as long as possible. Now the researcher gets in the middle and has to now connect all these things and make a prediction and a model and convince people. So the researcher has to take the composition and predict durability, predict strength, predict the long-term behavior, and so on. Finally, the administration, what do they want? They want less waste, buildings to last long, longer service life. And for the planet, what do you need? You need sustainability. Therefore, you need less energy consumed, less raw materials, less carbon dioxide. So this makes our sector and concrete so challenging. It's a simple material, but many, many, many people have to be involved and accept any change, and that is where things also go wrong as opposed to other sectors. So a lot of issues are there with concrete construction today. A lot of you will probably even see more issues, but I've listed some of the things which are of concern. There is a lot of cases of plastic shrinkage cracking. People complain that you take RMC, I used RMC and it cracks. I don't know if concrete OEM will have the same problem, but I'm sure they do not. But generally, this is a concern. Cracking. I'm using RMC, therefore there is a crack. I never got this when I did site mixed concrete. You have cracks appearing after a week, thermal shrinkage. Where did this thing come from? Long back it never happened. Who should test it? Should the RMC plant test it? Should I test it? How do I test it? What age should we test? GGBS and fly ash keep on gaining strength. Should we do it 56 days, 90 days, 28 days, or 7 days? Corrosion is a big problem. It's becoming a more and more of a problem as our buildings and structures last longer. Sustainability, as I told you, is an issue. Water. Unconventional concretes. We know the advantages of many new types of concrete. Can we use them? Can I just pick up the phone and say, deliver this concrete? So these are issues that are there. Probably there are more. If you have, I'd like to hear about issues that today are prominent in the construction sector. I like to focus on few things which I believe is important to revise. I'll go through it fast. If you have doubts later, we'll go over it quickly. Cracking is of concern. Cracks sometimes happen fast, in a few weeks, months. Some cracks happen very much later. Now, shrinkage is a cause of concrete cracking when there is no load yet on the structure. If it happens very fast, when the concrete is still fresh, it is plastic shrinkage cracking due to the loss of water in the plastic state. Then afterwards, especially when we use high-strength concrete with very little water, the concrete dries up internally. This is called autogenous shrinkage. Then the concrete also is picking up heat. So all cement reactions are exothermic. So the concrete is hot. If you touch concrete after 1 day or 3 days, high-quality concrete, you'll see it's hot. But the environment is cooler, so it has to contract. The outside is cooling, inside is hot, so it cracks. That is thermal contraction or thermal stress-induced cracking. Then you have drying shrinkage, which will happen over a long period of time. This is what all of us have studied. We have studied drying shrinkage. We have not studied mostly about the others, which are more important today because you are using less water, you are using higher cement content, you are using finer cement, you are using higher grades of concrete. Carbonation shrinkage, again, will become less and less important when we go to higher quality concrete. Anyway, this occurs over a large period of time. So it's very important, and this is important for consultants also. If you are a consultant and somebody calls you and say, my structure is cracked, first thing you should ask is, when did you see the crack? If they told you, I just concreted it and there is a crack, plastic shrinkage. If it has happened over a couple of days, 1 week, demolded, cracking, thermal shrinkage. Diaphragm wall is cracking after several weeks, then it is autogenous shrinkage. Okay? So this is something that we should start thinking about. We should start thinking about learning that if there is a crack, structure is not yet loaded, ask, when did you see the crack? And there we can understand what is the problem and think of what is the cure for it. Plastic shrinkage cracking is becoming very, very important, not only because of our climate, but we are using more cement, we are using cement that gains strength slowly. So one of the things that we have done in our labs is look at slabs of concrete, different types of concrete. We blast it with hot air and see how it cracks. And we find that if you compare ordinary Portland cement with concrete made with PPC and PSC, PPC will crack earlier if you do not cure it. It will also have larger crack widths. Okay? What do I do? I'm not telling you stop using PPC, PSC. We have to cure better. We have to cure faster. And when I talk to people and say, lot of people, when you say, when do you start curing? Lot of people say, next day. Right? I don't know if it's still prevalent. How many people will say differently? And if you made the concrete on a Saturday, when do you start curing? Monday. Because it's a holiday, no? Sunday, you don't expect me to come and cure the concrete. You cannot push your thumb inside. And this is very, very important for concretes which have fly ash, which have slag, and so on. If you cannot cure, then put a little bit of polypropylene fibers. Just 1 kilogram of short polypropylene fibers will help probably eliminate the plastic shrinkage cracking. Very simple cure. We don't have to panic. And this can be done and has been shown to work. Otherwise, you will have cracks like this. Pattern type cracking, random cracking, this is usually plastic shrinkage cracking. Okay? Thermal shrinkage, as I told you, happens later when you have thick elements like a raft. Professor Manu can talk about many, many case studies where he's been involved as a consultant. So you have cracks easily happening in rafts, podium slabs, all these things. We are making very thick elements. We are making huge columns. So there can be a lot of problems. What we generally say, I know that somebody here is going to say that these numbers are over-conservative. If somebody comes to me, and that is why most people don't come to me, when there is an issue of thermal cracking, I would say internal temperature should not be more than 70 degrees. Okay? And the gradient between outside and inside should not be more than 20 degrees. There can be exceptions. We'll discuss case by case when the case arises. But in general, the inside temperature should not go more than 70, because much beyond 70, concrete starts drying up, you have changes in the microstructure. And if there's a big gradient from inside and outside, the outside cools faster, and to accommodate the contraction, it cracks. So thermal temperature and heat is very, very important. So what should you do? You cannot throw your hands up and say, in India, I cannot now use concrete because the temperature is always high. Cool the concrete. We just heard from Jagannath Rao sir that you can deliver concrete at low temperatures. You can ask for concrete. Of course, you have to pay for it. You can ask concrete for at 25 degrees centigrade. You can ask for 28 degrees. How do they do it? You add ice instead of water, not in addition to water. Instead of the water, you add little bit of ice. Can be done. Can be done. So, if we decrease the initial temperature, your temperature rise will be less. Cost is going to be a problem. But you're talking about 100-year structure. Why don't you spend a little bit more? It can be done. Also, we can insulate the surfaces so that the cooling doesn't happen outside when inside is very hot. So, insulate the surface so that the temperature gradient is not that much. So, these are some of the things that we can do. And if there are questions, certainly we can take it up and discuss. I'll also want to touch upon two other things quickly. One is fiber reinforced concrete. And the reason is we are doing a lot of metro construction, and it's possible, there is interest being shown by several metro companies in India on using fiber reinforced concrete. And I'll rush through this. I might have talked about this to you or other people. So, lot of metro construction now is being done like in this video, where you have the lining being constructed with prefabricated elements. You make these elements outside, and as the TBM is going through the rock or the soil, it builds the lining. What is fiber reinforced concrete? It's concrete where you mix the fibers, so the truck comes to you with the reinforcement, with the fibers. What do the fibers do? They help arrest the cracks. They absorb energy, don't let the crack open. They are stitching the crack. So the crack is not opening. They are bridging the crack. Fibers are not added to increase strength. Again, some people say, I put fibers so strength should go up. No. If your strength should go up, decrease water cement ratio. Not add fibers. Fibers are not there at the dosages we use to increase strength. Okay? It's a misconception again that we have to get rid of. Fibers are not meant to increase strength. If I want compressive strength to increase, decrease water cement ratio, use a good super plasticizer, and ask for a higher grade. And there have been a lot of cases. This is a yard where the point load capacity, the axle load capacity was 100 tons that we did. Nearby in Chennai, we have overseen or we've checked the design for a large floor, prefabricated elements like this. We have done a lot of work, and we can help where you need help for warehouse flooring, shotcreting, and so on. In our campus, we have the luxury of trying out things. So if you come to our campus, you will see a lot of roads made out of concrete with fiber reinforced concrete, and they've been around since 2007. I think one of these roads was 2007 or 2009. The ramp at Chennai airport, where all the luggage trolleys go, if you've seen, the luggage trolley is going down. At one time, the Chennai airport could not open, the new terminals could not open because the luggage trolleys were slipping. So they panicked and said, what can you do? So we told them the way to increase the strength, put in fibers so that they could open in 3 days. This ramp was used in 3 days. Okay? So a lot of things are possible. We have to have the opportunity and be ready for it. So metro tunnel lining, there are opportunities. There have been cases. This is the case where long back we had sacrificial lining done for Chennai Metro. It was successful. Now again they are doing it. L&T people are here. They are people who are promoting this. So this could happen. In Patna Metro, we completed the entire design. It is waiting for the third-party designer to check, but complete design properly was done and defended, where we are looking at the complete metro to have just fiber reinforced concrete instead of regular reinforced concrete. So again, it's possible. The last thing I want to touch about is environmental impact. Everybody talks about sustainability. But how do we measure? Can we think of a number? Can we choose a concrete that is sustainable? So the technique that we generally use for quantification is called life cycle assessment, and I'll quickly go through and tell you how to do it, because we don't have a database. Our software are there, but we are not sure if it's ready for India or not. So what we did is went to different plants. I'm showing you this. It represents the different clusters, limestone clusters. I'll show you the results of one plant in Nandyal. So we go to the plant and ask them, what are all the things that went into your cement and clinker? For a ton of clinker, ton of cement, what are all the materials which go in? And we find things which are not there in textbooks. We find a lot of cases, or most cases, that there is no clay added to the raw meal when you have, I don't know if this is my phone or somebody. No, not my phone. Yeah, sorry, it's my smartphone, which is not very smart. So, in Nandyal, so we went there and asked them, what do you put into your raw meal to get cement? And we found that they don't use clay. They use a lot of other stuff. They use flue dust, red mud, laterite, GBS, and lot of waste material. In our cement kilns, we are already consuming a lot of waste. Lot of pharma waste goes in. And the story I always like to tell, probably many of you have heard, is you remember when Maggi noodles were taken out of the market? Yeah, who remembers? It was in the news, Maggi noodles were taken out. Anyone remember the story or no? Yeah? What was in the noodles that you had to remove it from? Lead. Yeah? Lead. And therefore, it was taken out of the market. So Nestle had to take all these packets of Maggi noodles. Where do you think they went? Where do you think they went? Into Ambuja cement. True story. I'm not bluffing. True story. So it went into the kiln. So all sorts of things go in. So cement is good. When people complain to you and tell you cement is bad, tell them, where will you put so much of junk in other than cement? So cement is a good sink for certain things. Whichever has calorific value, you can do. And also fuel. We believe that it's all coal we are burning. No. We are using pet coke that is not used by other industries. So there are a lot of good things about cement manufacturing that you can learn. But our concern is, what are the emissions? We find that there is a lot of carbon dioxide coming out with every ton of clinker, about 900 kgs in this particular plant for a particular time. It can vary a little bit. For every ton of clinker, there is at least 900 kg of CO2 emitted. Lot of it is coming from the conversion of limestone to calcium oxide, from the burning of the coal and so on. There is a lot of energy also which is needed, fossil fuel. Can we do something better? People are working on it. Now, if you calculate for cements, different types of cements, the good thing that comes out is when you go from ordinary Portland cement to PPC to PSC, you reduce the CO2 without sacrificing strength or durability. Durability can even become better. The only thing is your early strength that you have to design for. So actually it becomes better because you decrease the amount of clinker. Same thing with energy. Now if you go on to concrete, again you find that concrete with fly ash, with slag has less energy, less carbon emissions. Higher grade concrete is even better. It's more efficient to use higher grade concrete. So if you have a choice between M20 and M30, use M30. It is going to give you better durability, smaller elements, you have less carbon emissions, more efficient. So the question is, it's nice to talk about all this. How can I choose at the site a concrete that is sustainable? There are infinite mixed designs. Lot of mixed designs can give you the strength and workability. How do I choose? So what we said is, can we put together strength, workability, carbon emissions, energy, and durability together? And we came up with two numbers. One is called the energy intensity, which is energy consumed for making a cubic meter of concrete divided by the compressive strength. So we keep in mind the compressive strength also, which is important for the structural stability and safety. And we find that this energy decreases as you increase strength. And it flattens out. It's not that you should use very, very high strength unnecessarily. Higher the strength, mostly, it will become more efficient in terms of energy per megapascal of strength. The other thing we call an apathy index. Apathy means you don't care, because most of us don't care about durability, don't care about carbon emissions. You are listening to me because you have to. Otherwise, you don't care. So we said this we have to decrease. This apathy we have to decrease. So we came up with an index of carbon emission divided by durability, and we call it an apathy index. And what we found and what we see is, out of different choices of concrete, if I make a plot like this, with y-axis I have apathy index, x-axis I have energy intensity, what is in the lowest corner is more sustainable. Because I've tried to take into all these 4 aspects and come up with this number. You can do it for a lot of concretes. We did about 30 mixes we analyzed, and same. So this means that you have a choice. You can choose. Generally, if it is chloride attack, you will see slag is better, fly ash is better, ordinary Portland cement is the worst. We think ordinary Portland cement is the best. It is pure cement. It is the worst for concrete in Chennai. If you are making it on the coast, it is the worst concrete you can use. And that is what Professor Manu Santhanam will be talking about in the following lecture. So we've done trials. We've done all these LC3 things. We have shown how it is important. And very importantly, we have done a bridge also. We are just not talking lab stuff here. We are not talking theory. It is not just a paper. So one of my colleagues, Radhakrishna Pillai, has the tenacity to convince people. So he went and made sure that the middle span here was left to us to design the concrete. The other spans are ordinary Portland cement. In that chart that is up there, the red and orange are the other 2 spans, extreme spans. The middle span, we were allowed to change the concrete. We use our chart and brought it down to the green and blue. This is what I'm talking about. We can change. No sacrifice of strength, no sacrifice of workability. However, my life goes up to 125, theoretical, obviously. Theoretical, calculated with proper models. From 30, it goes to 125. Carbon dioxide savings in just one span, 230 tons of CO2 has been saved by looking at durability also, in addition to the usual strength and workability. We had a chance to work with L&T on the foundation of the Ayodhya temple. Again, you might ask, Professor Manu Santhanam was heading the team, so he can give more details. So you can again ask, 1,000 years, you guys are going to be dead. Of course, we'll be dead. But we have models which can show that you can have. And it's not a secret. What would you do if you have to design for 1,000 years? What is the first thing you will do in a foundation? Somebody. Otherwise, we are not going to have dinner. What is the first thing you'll do? Huh? Loudly, madam, you have to shout, otherwise you cannot hear. Yeah? What would you do? Lining. Mining. Piling. No. Yeah, pile also you put reinforcement, no? Yeah, we started off with piling. We can tell you a lot of stories of the piling. No steel. First you have to remove the reinforcement. Okay? Now you have to change your mindset. You have to forget reinforced concrete design 1 and 2 and advanced concrete design and all that you forget. You think of concrete now as a rock. And you have to design as if it. That's what was done. So layers of concrete were poured to give this raft on which the Ayodhya temple is sitting. So to conclude, if you are talking sustainability, we have to think differently. We have to think about low carbon cements, higher quality construction, extending durability, which is very, very important, and you will hear in the next lecture. Recycling has to come in. We have to start recycling. We have to decrease the water demand because water is a precious commodity. People say that few wars soon will be fought for water. And we have to look at new composite systems. Why the whole thing? Why the same thing? Why can it not be different? So with that, I'll stop. Thank you very much. So maybe we can take questions later together? No, should we take questions after, let Manu finish and we take questions together, Manu? Yeah?
Yeah, so we'll have it together.
Yeah, I think so.
And inspiring words. And ladies and gentlemen, it is our privilege and honor to introduce our next chief guest, Dr. Manu Santhanam. We are truly fortunate to have you with us today to hear your valuable insight that will surely inspire and guide us. I invite Mr. Jayesh, our Vice President, to officially introduce Dr. Manu Santhanam. Jayesh, please.
Good evening. Thank you, Professor Ravindra Gettu, sir. It was a really enlightening lecture. Especially you taught us how Ayodhya temple was built without steel. And how Chennai, which is actually having a lot of scarcity of water, maybe 10 years down the line, sewage treated water will be used for concrete purpose.
Sooner than 10 years, I hope.
Yeah, true. Thank you. So now I would like to introduce Professor Manu Santhanam, Dr. Manu Santhanam. He is a BTech from IIT Madras, MS and PhD from Purdue University, USA. And his professional affiliations are member of Indian Concrete Institute, member of American Concrete Institute, senior member and fellow of RILAM. His awards and honors include Indian Concrete Institute Fosrock Award for Outstanding Concrete Technologist in 2018, fellow of Indian National Academy of Engineering 2024. He has more than 150 journals and publications to his credit. Now I request Dr. Manu Santhanam to take over and do the presentation. Thank you.
Thank you. Can you all hear me? So very good evening to all of you. Indeed a pleasure to interact with such a big audience. I think kudos to Concrete OEM for calling so many people here, engaging in a nice technical meet. I hope that you will have enough questions for me and Professor Gettu later on, because these are subjects that you just can't get enough on, because you have to ensure that you are practicing concrete the way it needs to be done. There's a lot of important things about concrete that sometimes get missed because we are always in a hurry to complete our construction projects and get on with the use of the building. But I think the more attention we pay to the concrete, the better our structure will be and last longer. Now, of course, Professor Gettu talked a lot about how you need to look at making your structures durable. But oftentimes we find that even though if we do a good design for durability in the lab, implementing durable concrete in the field often is a challenging scenario. And much of it happens because the processes and the specifications that we currently have do not really seem to have a clear understanding of how we can actually translate the lab effort to field. So I'm going to talk primarily about that, challenges in implementation of durability design and concrete construction projects in India. So much of it will be based on, of course, some experiences that we've had consulting with different companies and trying to understand how concrete in the field actually behaves. That helps us a lot in embellishing our lectures in the class also. Hopefully it encourages our students to also look at concrete technology as a profession to follow on. So I'll talk a little bit about how durability design is typically done. How do we control durability on site? What are the different approaches on site for durability design? In the Indian construction scenario, how is concrete utilized? What are the different types of concrete that are used? And where durability design is typically applied? And that's something which maybe the audience here may also be well versed with, but I'm sure that they can also give some more pointers if I'm not perfectly right in my assessment of what kind of concrete is being used and how much of it is being used. Then I'll talk primarily about durability design of special concrete and look at some issues related to specifications, site-based control, and cracking. Of course, cracking, Professor Gettu has already introduced this subject earlier, but I'll touch upon a few case studies where some pre-planning could have helped in avoiding much of this cracking. Right, so again, this is something that if you've heard me talking on performance-based specifications, our team at IITM talks about this everywhere. The idea is that we are moving increasingly from a prescriptive approach to a performance-based approach. What this means is I do not need to know what exactly is there in the concrete as long as it gives me the right performance. Just like when you buy a light bulb, You go to an electric store to buy a light bulb, and you don't necessarily have to find out what the thickness of the filament is, right? As long as the person in the store is able to put the bulb in the socket and show that it's working, you believe that it's fine. So that's the idea of a performance specification. Of course, in concrete, we can't say that, okay, put the concrete, then I'll see how it behaves. So there, you need to control it, obviously. You need to control the performance or understand the performance using some indicators, which are basically performance indicators based on accelerated tests that can help you give a quality ranking to the concrete mixtures that you prepare in the laboratory, right? And when you actually are going to be translating this to site, you have to do a field-based demonstration also to ensure that you can actually qualify the concrete as suitable for, I don't know. Okay. Maybe this is getting, I can stand here also, doesn't matter. It's off? Okay, fine, sorry. Yeah, so performance-based tests are typically available. Maybe we'll just use this. Yeah. Okay, right, thanks. Yeah, so currently what we typically follow in our codes for control of concrete durability is a prescriptive approach where we say that, okay, you need to have so much cement, you need to follow, you need to design your concrete with so much water cement ratio, so much strength in order to meet the demands of durability in a particular service environment. But when I look at performance approaches, I'm not really worried about that as long as I can justify that my concrete is going to perform in a certain way. Obviously, this requires a lot of understanding of how these tests work, what are the limitations of these tests, and how many of these tests you need to do to ensure that what you're actually producing in the lab will actually make it properly on site. Now, as we gain more experience with these tests and understand what the results mean, obviously we can we're able to predict the properties of concrete. Approach. Now, in India, a lot of the concrete is actually unregulated. More than 70% of cement produced in India goes towards residential construction projects. This includes, of course, masonry blocks, plaster, and site mixed concrete. All of you are aware that a lot of this concrete on site is volume batched, right? Where we have absolutely no control on the extent of water that you add in the concrete. So we are not even talking about durability in those cases. We've also had cases where in construction projects where beams and slabs are cast using ready-mix concrete, which is of a good quality, the column cannot be cast with RMC because you don't have required volume to be actually produced and supplied through RMC. So that is site mixed, and that often gives more problems also. So what we have is, of course, potential for use of special cements. We talk about this residential construction. Thankfully, in India, for residential purposes, the cement has moved from OPC to PPC almost completely. We have had a major shift in the way that we use our cement. A lot more PPC and PSC is being used. Quality control on site in such unregulated products is generally poor, right? Again, masons who are not perfectly trained in concrete technology, who are just going with whatever experience they've had, are driving these kinds of projects. Common issue, of course, is poor compaction, excessive bleeding, and cover concrete is sometimes poor or sometimes non-existent. We can see sometimes steel at the surface. So I always call this as manual 3D printing. You take plaster or concrete and put it on top of the steel to cover up the surface. That's often a case in many of our unregulated projects, right? Now, I don't know, this is a tongue-in-cheek comment that this creates a constant demand for repair. So people are always engaged in doing something or the other, and this profession itself remains sustainable. People can continue to work. jobs are continuously there. But this is not what we want. As engineers, we want to do the job and ensure that we are able to produce a structure that is worthwhile and that is capable of living for a long period of time. Now, major part of the concrete from batching plants that is supplied to all of these projects is of low grade, typically 35 megapascals and below. There again, there is really not much of a durability design that is attempted for concretes of this kind of a grade, right? When we are talking about durability design, we talk about infrastructure projects and where the grades are typically more than 35 megapascals. So, special concretes in such projects where not much regulation is there, where not much engineering actually happens, is quite low. But it is still there in cities and in major infra projects where people are increasingly using different types of special concretes. So, what are the different types of special concretes that are used in India? One is, of course, self-compacting concrete. Today, a lot of projects in India are being done with SCC. High-rise construction projects in cities are employing more and more of self-compacting concrete. High-strength concrete is being used quite a bit. Of course, not as much in Chennai as it is in Mumbai. Mumbai actually has a number of projects where grades of concrete up to M100 are being used. Fiber-reinforced concrete, Professor Gettu talked about it quite a bit. FRC is increasingly being applied for industrial flooring where it finds the maximum application. Also, of course, for tunnel linings, whenever in metro construction, that's become a huge opportunity now. Radiation shielding concrete is a special type of concrete where we use heavyweight aggregate, and it's used in nuclear reactors. And grouts for pre-stressing tendons. I mean, we have been advocating, Professor Pillai and our group at IIT Madras have been advocating the use of pre-packaged formulated grouts for pre-stressing tendons to ensure that the tendons are protected against corrosion throughout their service life. And there are also other new applications like geopolymer concrete and 3D printed concrete that are increasingly gaining prominence because there are niche applications where these can also meet the demands. Now, there are special applications, so types of applications that require special concretes. We know that mass concrete for rafts and shear walls often combines the concepts of self-compactability and high strength, especially shear walls, where high strength is typically needed. And in most cases, because of the reduction in the effort that you need for construction, it's often advisable to go with flowable concrete like SCC. Tall buildings and viaducts, mostly self-compacting and high-strength concrete is used, and viaducts, post-tension grout is also being applied quite a bit. Industrial floors, as I discussed earlier, self-compacting and fiber-reinforced concrete find a major application there. Nuclear reactor structures, high-strength concrete and radiation shielding concrete, and monumental structures also use a lot of special concrete, especially self-compacting and high-strength. So, realistically, if you look at all of the concrete in India, 90% of durability design scenarios will actually deal with such special concretes, because unless we really have a clear understanding of what the longevity of the structure that we need is, we are not really going to invest a lot of time and money into setting up the test protocols that are required for durability. So 90% of the time, when we are talking about durability design, we are looking only at special concrete. So I'm going to talk about special concrete and what are the challenges in implementing these durability considerations when it comes to the site. One is specification. There is always an emphasis on minimum cement content in the specifications, right? Now, cement, if you even look at IS 456, many people don't seem to interpret this well. When they talk about the minimum cement content required for durability in different environments, it clearly says at the bottom of the table that it's inclusive of all the additions, right? When I say 360 kilograms cement in an extreme environment is needed, it is inclusive of fly ash or slag or silica fume or any of the permitted additives as per IS 456. Unfortunately, not many people pay attention to that. They still say minimum cement content. There is no clear guidelines on quality assessment of SCM, supplementary cementing materials. That is one of the problems why people have not been able to adopt SCMs as much as they should be, because very often the fly ashes that get supplied to ready-mix concrete are not properly, do not have the right quality. And oftentimes the people who are supplying the fly ash do not ensure that the quality and the consistency of this fly ash is maintained from batch to batch. If you go to Western countries like the US, fly ash is available like a commodity product, like cement. You can buy bags of fly ash, and you can guarantee that these fly ashes are satisfying a certain physical and chemical performance. And that really helps to push the case for regulating some of these materials to ensure that they're used in a better fashion. The exposure classifications are not updated. Of course, this will change soon when we have our new IS 456 coming up. I'm hoping that within the next couple of months it will come out for wide circulation. So you will actually be able to see a lot better coverage of exposure classifications, which is important to understand what are the kind of durability problems that are expected in a particular exposure environment. There's not much coverage of durability testing in the specifications typically. And even if the durability tests are specified, there is no idea about the frequency of testing. How often do I test durability? Is it as often as I test strength? One needs to understand how these durability tests work to really figure that out. And there's no mention of durability planning. Now, it's very important for a structure that's coming up, which needs to have a design life of 100 years, that you need to spend a long time to plan how we are going to achieve the durability on site. It's very easy to do tests in the lab and say that, okay, I've got less than 1,000 coulombs RCPT. Yeah, but then what happens at the site? What kind of variability in the concrete will I get? How will it affect my life cycle? So all those things need to be answered properly. And again, there's also a lot of lack of information on specialty admixtures like corrosion inhibitors. Very often I've seen specifications where they are using integral corrosion inhibitors, but the test method in the spec or the test that is specified is actually that for a migratory inhibitor. So one needs to clearly understand what are the different tests by which you need to assess the performance of these materials in order to deem them suitable for the concrete mixture to be used on a project. And again, when you test for durability, you need to look at acceptance criteria. You have to accept that there's going to be some variation in the site supplied material. Even for strength, acceptance criteria are fairly well defined. We have to do the same in order to be able to get the best out of durability test methods once they are applied to production concrete. Some examples of specification challenges and what kind of issues came up because of that. There's one project, I'm not going to name any of these projects, they're just some projects that have been done where I was involved in one way or the other. Here in this project, about 65 MPa concrete was being designed. And as per the spec, minimum of 450 kilogram per cubic meter of OPC was mandatory. It's not cementitious content. 450 kilogram of OPC was mandatory, right? And the spec also said that the temperature needs to be maintained to less than 50 degrees Celsius all the time. Inside the concrete, the temperature should be always 50 degrees or less. Now, any rough calculation you do will show you that 450 kilograms of cement will lead to a temperature rise of more than 50 degrees Celsius. Whatever temperature you cast your concrete at, you will get a rise of more than 50 degrees Celsius. So that means if you have to ascertain your concrete remains below 50 degrees, you have to do concreting at 0 or negative temperatures. Who's heard of these kinds of things? Unless, of course, you are planning to use cooling pipes inside your structure that will ensure that the concrete will remain cool less than 50 degrees all the time. So again, this is an issue with the specification. They have not really understood what is the impact of using high amounts of cement on the heat generation inside the concrete, right? And of course, in this case, the contractor also did not bring up this issue during bidding, which got them into trouble later because the concrete actually on site was exceeding 80 degrees Celsius, right? And they had to do a lot of explaining, the payments got delayed and so on and so forth. So again, a spec has to be carefully monitored, things have to be understood as to what is written in the spec, and we need to plan to ensure that such kind of issues don't really show up. And one more thing was the spec also did not place a stringent requirement on the placing temperature. They did not say that, okay, since we are asking you to keep the concrete so low in temperature inside, you should place at a very low temperature. They didn't say that. The second project, it's a simple issue. I've already talked about that. The corrosion inhibitors were specified to be added integrally, but the test specified for inhibitor was pertaining to migratory corrosion inhibitors. So it really did not make sense that this test was there in the spec. In this project, Project C, the RCPT, Rapid Chloride Permeability Test, Coulomb charge passed value, control value was specified as 1,000 coulombs. That means any concrete supplied needed to have an RCPT value of less than 1,000 coulombs. But the contractor was not permitted to use fly ash in the concrete mixture, okay? Because if you've worked with RCPT tests, you'll know that any ordinary Portland cement concrete mixture of a grade of 40 to 50 megapascals is not going to get you 1,000 coulombs. Unless you have a water cement ratio of very, very low in a clean concrete mixture, you'll not get that. You have to use siliceous supplementary cementing materials like fly ash. So in this case, of course, the contractor was coming up with an interesting solution. They said, okay, we'll not use fly ash as a replacement of cement. We'll show it as a replacement of sand. So they had fly ash in the mix. Ultimately, they got the concrete to show an RCPT value of less than 1,000. So again, it's not cheating, but what you have done is essentially not reduce the cement, but increase the cementitious content by showing the fly ash as a part of or partial replacement for the fine aggregate. Now, there are issues with site-based control that we have to deal with, and that's where durability planning becomes very necessary. Most of the quality control labs are not well equipped with durability test equipment, right? Usually, irrespective of the environment and the kind of tests that need to be done to a certain durability, usually it's found that only two major tests are done at every site. One is RCPT and sometimes water penetration test under pressure. So these are the two commonly used tests in most sites, but these don't always address the quality of the concrete or the assessment of durability in specific environments. The one major peeve I always have is in big construction projects also, oftentimes ice plants are not set up to handle the concrete temperature issue. And this is a real concern in my opinion, because we're increasingly dealing with massive concrete structures, we're increasingly dealing with high strength concrete and mass concrete, which is again baffles me. I don't know why specifiers or designers are putting high strength concrete and mass concrete. Nevertheless, I'm not questioning that right now. I'm just saying that you need to set up ice plants to ensure that the concrete temperature can be controlled well. Early shrinkage cracking, there is not enough preparedness on the site to handle it. And again, this planning needs to go in before, in case you really need to prepare a structure without cracking. And sampling for quality assessment is sometimes incorrectly done or sometimes not done at all. And quality of curing water on site is again not addressed properly. Now, again, this is something that we have seen very often, that curing water, if people start using groundwater which is rich in chlorides, it can result in disastrous consequences. Some examples I'll give you again of site-based control where it led to problems. In the first project, 35 megapascal self-compacting concrete was used for a raft of 1.5 meter depth. Placement temperature desired was under 20 degrees Celsius. So here the spec said, you have to make concrete under 20. There was no ice plant on site, but crushed ice was supplied. Luckily here, because the cement was replaced massively by fly ash and slag. 70% cement was replaced, 40% by fly ash, 30% by slag, because of which, even with this control of the water quality, of the water temperature, we could still manage the concrete to be less than 20 degrees Celsius. In the second project, which was actually a building right inside IIT Madras, there was a large terrace slab which was placed with continuous concreting with 35 megapascal SCC, right? At the previous floor levels, the concrete was placed over a period of 8 hours during the night. Now, we heard from Professor Gettu about plastic shrinkage cracking. The important thing obviously is to ensure that you don't allow the cracks to develop when they start developing, so that workmen have to be there on the site. In case early curing is not done, people have to be there on the site to see where cracks are appearing, use a wooden float, rub it. Very simple way to actually ensure that the cracks go away in the beginning. No workmen were there on the site. People came back the next day. Lo and behold, lots of plastic shrinkage cracking. You have to have some statements of methodologies to repair these cracks to ensure that the water does not seep through and so on. Additional cost, which could have easily been avoided by having extra workmen. So again, next time this placement was done for the higher floor, the terrace of the next floor, the slab for the next floor, there was a large team of workmen to observe cracking and float immediately. Absolutely no cracking was there. This was all self-compacting concrete. And no cracking was there when these workmen were there on the site to ensure that they could do the floating when the cracks appeared. And this is very early, during first couple of hours after placement, that you start seeing these cracks. In this third project, 50 MPa concrete was supplied for a column. So as is usually the case, the truck arrives on site. First it goes to a QC lab, dumps the concrete required for preparing your cubes and cylinders and the other quality assessment in terms of workability, then it goes to the site and delivers the concrete. In this case, as it turned out, when it went to the site was not prepared. The reinforcement was not ready, formwork was not properly ready, and so on. It took some time for the concrete to be actually put in the structure. Now, when concrete gets delayed on site, what happens? What happens when concrete gets delayed? Slump gets reduced. When slump gets reduced, the old technique was to put water to increase the slump. Luckily, people have understood that this is a problem. More water means less strength, less durability. Now we start adding admixtures. We start adding chemical admixtures to ensure that we can retain the slump. Now here, they overdosed so much that the concrete just did not set. The next day, the foreman saw the concrete, top of the concrete had dried, so they tapped the top of the concrete, thought it was dry, and opened the column formwork. The entire column collapsed. There was absolutely no setting in the concrete. And actually, on the third day, when I went to the site, the concrete still smelt of sulfurated naphthalene formaldehyde. I could smell that admixture, that it was overdosed so much. And then I went to the lab and I saw the cubes that they had cast from the same batch of concrete. The cubes were perfect. We tested the cubes, they gave perfect 3-day strength. Right? So this goes to show that, one, you need to ensure that the sampling for the strength is done at the point of discharge of the concrete. If the cubes had been prepared at the time of discharge, we would have understood that these cubes are not setting. Something is wrong with this concrete. Right? But instead of that, they opened the formwork, concrete collapsed. That the site needs to be prepared when the concrete is supplied. You can't keep waiting. I often link concrete with cooking. Fresh food always tastes better. Fresh concrete always performs better. Now, early age cracking, again, I don't know how many of you were there in the talk yesterday. I'm sorry that this is a bit of a repetition. And I talked a little bit about early age cracking yesterday. Some of those examples are again here. Plastic shrinkage cracking, obviously, is a common issue with special concrete. As Professor Gettu was mentioning, the more additives that you have, fly ash, slag, chemical admixtures, and so on, your propensity to crack goes up. Okay? So you need to plan how you are not going to get this cracking at all. An emerging issue is thermal cracking. One, again, specs don't place stringent requirement on the placing temperature. Temperature rise study is not mandated unless you're doing a mass concrete like a dam or a massive raft. But these days, many of the columns and shear walls in high-rise buildings and all our viaducts, these are all actually classified as mass concrete because they are 2 meters thick, 3 meters thick, and so on, right? And temperature development models are not used. Improper and very often these models are necessary to understand when do I remove my formwork. Because again, one more aspect that Professor Gettu alluded to was that you can actually insulate the members to ensure that the heat loss does not happen from the sides and that the temperature differential can be minimized. So here, in massive structures, it often helps to keep the formwork on for as long as possible to ensure that heat does not get dissipated fast. And it's preferred to use plywood formwork instead of steel to ensure that the heat does not go away very rapidly. And there is no clear plan for curing. Very often we look at all these massive concrete structures also where simply they remove the formwork, start pouring water directly. The problem is if you already have a temperature differential, pouring water is going to increase the temperature differential and you'll certainly get cracking. Sometimes we have cracking due to external restraint. Sometimes we are in a hurry to place longer stretches. And when you do that, if you don't provide sufficient reinforcement, you are going to have a problem. So this is, again, plastic shrinkage cracking. This project is, again, the same terrace slab that was placed with continuous concreting using 35 MPa SCC. This is the same example I talked about earlier. We had workmen at site to ensure that the first time when we didn't have workmen inside, the plastic shrinkage cracks appeared, as you can see here. Right? If you don't attend to these cracks, they will grow. They will grow, sometimes reach all the way to the bottom, and water will start seeping through. So next time, we had these workers with a wooden float, ensuring that you don't get these cracks forming. So you need to have these people available on the site in the first couple of hours after placement, or at least for the first 6 hours after placement. Now, here, this is a shear wall of a multi-story building with 60 MPa concrete. There was no clear plan of temperature control in this case. People didn't think about it. They just stuck the formwork at 24 hours, just like usual. And at that time, it was actually a peak core temperature of 75 degrees Celsius. But no temperature modeling was done, so they didn't really know what was the peak temperature inside. And as soon as formwork was removed, they started pouring water, and obviously cracks like this appeared. This is a shear wall of a multi-storied building. You can imagine this kind of cracking is not good in a shear wall. Same image here. And of course, after the cracks appeared, they started doing temperature monitoring, and then they started placing requirements for temperature control of the concrete. This was again another project in which a plain concrete draft was done with 35 MPa self-compacting concrete. All precautions were taken to ensure that plastic shrinkage cracking could be avoided. But here, one issue that came up was the length of placement was about 27 meters, and these were 9 meters wide strips. So massive. Because of all the precautions that were taken to avoid plastic cracking, it came out absolutely beautifully. The top surface showed no cracking at all the next day, right? But the problem was, since the base was so long, 27 meters, concrete had to show that joints are necessary. So it automatically cracked after about 10 to 14 days in perfect strips of 9 meters. Now, that doesn't mean that it failed. It just showed that that should have been the size of the slab that you first did. And actually, if you follow some well-designed, defined design procedures, you'll know that this is actually true for the kind of depth of the slab. More than 9 meters placement is likely to result in a very high levels of stress. So subsequent casting was done 9 by 9 meters. There was absolutely no issues in this project. So this is again showing you the top surface perfectly. Cracking. All the possible precautions were taken. And this is the cracking that actually appeared because of the base restraint. Right, just to summarize, I've talked about several issues. It's important to have durability planning as a key to any project, especially those involving special concrete. We think that when we use special stuff, it's going to, it doesn't need so much of attention from our part, but we are wrong. The more special the materials in your concrete, the more quality control that is demanded in a construction project. Specifications have to be carefully written. Each job is different. These days, of course, cut and paste is gone. Now we have AI. We can get AI to write specifications today, but AI cannot understand the site requirements are different. AI can have its place in understanding what kind of aspects to bring into specifications, but we have to be having NI to use the AI. If you don't have NI and just rely on the AI, we are simply not going to be able to execute projects well. Okay? Site should be prepared for operations expected for the needs of the special concrete. Again, if the special concrete is likely to result in very high temperatures, the site should have an ice plant to ensure that the concrete can be supplied at a controlled temperature all the time. If the concrete is having a propensity to crack, we have to take all possible measures to avoid plastic shrinkage cracking. And again, cracking is very important to resolve. Again, for durability, we know that we use special concretes of low water cement ratio, high supplementary cementitious materials dosage, higher strengths, and so on. But what's the point of having durability when you have cracks, right? Water or chemicals will not find their way through the concrete. They'll go right through the crack. Why do they have to worry about trying to penetrate through dense, impermeable concrete? You need to have crack-free concrete. Only then you can actually execute projects which can last for a very long time. Right, thank you all very much.
Such an insightful and enriching presentation. My dear friends, now it's a time for a question answer. May I request Dr. Ravindra Gettu to also come to the dais. And you are free to ask questions which is relevant to the subject. Both of our prominent lecturers will answer to your questions. And our team is there in the auditorium to facilitate you to ask questions. Their mics are there. So may I request everybody to use this opportunity and ask questions to our both eminent personalities and clarify your doubts. Sir.
Is there a microphone for the questions?
Your phone is there, hand mic, sir. Our volunteers are there. Suppose you want to ask a question, please raise your hand. Our volunteer will come and give you the mic.
Shall I? Good evening, sirs. In fact, primarily I would like to ask Gettu sir, while doing your presentation, you are mentioning about the
Yeah, go ahead.
the shrinkage tends to be more when you are using a PPC or PSC, or you need to have some quick curing when you are using blended cements. So generally, what we have been understanding so far is primarily, being, added with fly ash or GGB. I mean, fly ash or GGBS. Your heat of hydration will be much lesser, and then the concretes tend to shrink less when you are using PPC or OPC. So you are sounding differently. Then what is the technical reason or logic of saying that while using OPC or PPC or PSC, the cracking would be more or the shrinkage would be more?
So shrinkage, again, I told you there are 5 types of shrinkage. Certain types of shrinkage will be less. Thermal shrinkage will be less. Maybe drying shrinkage is also less when you have blended cement. But plastic shrinkage is occurring because of evaporation. So if you have a hot day, lot of wind, then there is water which is removed from the concrete. And this creates tensile stresses. The tensile stresses need to be resisted by the tensile strength. We know that blended cements lead to slower gain in the tensile strength. Therefore, tensile strength is also less at a particular time. So by the time this evaporation is occurring and stresses are developed in the concrete is not strong enough to resist. So it cracks. Further, if you put a lot of fine materials, there is a lot of capillary stresses inside, which increases the strains and therefore the cracking. So you have to understand when the cracking is occurring.
Okay.
Mechanisms are different and we have to understand it. What we know very clearly is if you go for blended cements and you do not cure, cracks will occur earlier and wider when you have blended cements, if there is plastic shrinkage cracking.
Okay.
Less water, more of blending will give you higher chances of plastic shrinkage cracking if you do not cure or do not have the polypropylene fiber inside or do not have an admixture. There are also admixtures which can reduce shrinkage. So that is also something that can occur.
Okay, thank you, sir. And for coming to thermal shrinkage, maybe this will have a better resistance, I guess.
Thermal shrinkage, the thermal stresses will be less because you don't have so much of heat.
Heat coming in.
So much of heat. So it can take more time. And that time, the strength also is picking up in the concrete.
Got it, thank you. So one more question primarily to Manu Santhanam, sir. Sir, you were mentioning about service life modeling. What exactly this is, and then can you explain a little more about service life modeling?
Yeah, so service life modeling means you're trying to assess the maintenance-free life of a structure. Typically, when you talk about durability, the primary mechanism of deterioration in durability is corrosion of reinforcing steel.
Yeah.
So, to model the service life against corrosion or service life in a corrosion environment implies that you judge the life of the concrete before corrosion will initiate in the reinforcing steel. So, for example, if you are going to be designing a concrete structure for 100 years, your modeling should clearly show that in a chloride environment, supposing you're in Chennai, the chlorides will not initiate the steel corrosion in that 100-year period. That's what is service life modeling. You have to use some approaches for modeling, which are defined based on some scientific laws, which look at how chloride diffuses into the concrete and builds up on the steel surface to cause corrosion. So that is what is service life modeling. So that means before you even do the concrete.
Does it really give a rational understanding on the durability, this modeling?
Yeah, as long as you are able to pick a clear parameter that reflects the durability of the concrete in a chloride environment. We call it the durability diffusion coefficient against chlorides. So if you have a way to measure it, you can use that to check the service life of the concrete structure. That defines what is the useful life of the concrete before corrosion of the steel gets initiated. That is called service life modeling. You can do this for other durability issues also, like carbonation-induced corrosion, sulfate attack, and so on.
Okay. Thanks, sir.
Good evening, sir. Both explained well. What is the remedy for crack avoiding in the concrete? Because we promptly using, as you said, the masons under the control of masons, uneducated persons like low level at foreman level people are using the concrete, handling the concrete. So how can we arrest and how can we get the good concrete? Whether RMC can have a setup, a team kind of, so who can handle the concrete to the site, like curing procedures, procedures, everything. Is it possible? And can we have the reaffirmation, like we can add it in the IS code of practice and reaffirm it so that everyone can follow in the field?
Yeah, I mean, that's a good point. How do we improve the condition of concrete that is not regulated, not controlled?
Yes.
Right? So, one thing is the kind of issues that you see in that kind of an unregulated practice are not exactly the same as what we have shown here. There, the issue is more because of an excess of water being added to the concrete.
Yes.
When you add excess of water, there is a danger obviously of having a higher water to cement ratio on the cover, and that's going to affect the overall service life of the concrete, of durability of the concrete, right?
Yeah, yes.
The other issue is of course that it's also going to give rise to weak cover zones. Strength also will be lower of the cover surface. Bleeding will be high. Segregation may be there because multiple handling is happening. A lot of people are carrying this concrete, right?
Yes.
And oftentimes compaction is not done properly. So the kind of problems that are there with site, unregulated concrete at site are slightly different as compared to what we discussed here. But yes, some level of knowledge dissemination
Yes.
is very important because I think people don't pay that much attention to concrete because they think it's a forgiving material. I know Professor Gettu also always says a forgiving material. But I mean, if you do all kinds of wrong things with it, it will definitely not forgive.
Yes.
Yeah, but you're right. Some hand-holding is required to people on site.
Because what R&D we do?
One aspect I've seen in congested areas where you can't really get RMC supplied is supply of RMC using bags and buckets. So at least a good quality concrete can be supplied for the construction project.
Thank you.
Yeah, yes. Good evening, sir. Thank you for giving a better presentation on the practical and theoretical knowledge to most of the people's gained our knowledge, out of which the usage of STP effluent, because recently all the developers are going with a massive construction where a lot of residential developments are happening, 1,000 units to 3,000, 4,000 units across the country. So the collection of sewage water, because there are a lot of systems available in the treatments. Parameters are varying. So as I rightly suggested, usage of final effluent can be utilized for the concrete manufacturing and other aspect like curing. Because in environmental clearance itself, they are very specifically mentioning about the usage of the final effluent. Most of the people's discharging the effluent into the ground only by means of recharging wells. For concrete, people's always having the just oscillation whether can be utilized because it is from the source from sewage. In foreign countries, I think that sewage water itself started for drinking. To my knowledge, I heard about it because for concrete production, potable water is required. The parameters, because the parameters are not going to be same uniform as prescribed by the manufacturer, the STP plant manufacturer. The operation is involved manually. So how to regulate the maintaining the water parameters for the concrete? Because we have done few sampling where it is all non-structural elements. So like cover slabs and like mud concrete, all those things we started practicing for non-importance works. For getting to the structure, because it is designed for more than 50 years to 100 years, the confidence into the engineering community is, the guidelines from the institutions are very much needed. So definitely it is going to be eye-opening for all the developers and then cautious on usage of the water for the construction industry. So it is a request from the engineering community to guide us on this. how to take it about it. As well as this plastic shrinkage, as I rightly mentioned about the practical difficulties in high-rise construction, maybe after placing the concrete, it is a majority self-compacting concrete only. In the horizontal diaphragm, like slabs, after maybe 1.5 hours, 2 hours, it is get hardened, and we started monitoring that plastic shrinkage and started doing all the exercise. But however, at later stage, these locations are impregnated. I think it is almost to the depth of the slab, and we have noticed few of the locations, few of the project in India, where this water seeps through, and there are a lot of water treatment, waterproofing system we are envisaging to arrest the leak. So any kind of methods that can be after the plastic shrinkage, anything monitoring aspect need to be done from our engineering team. Can you guide on this, sir?
Well, plastic shrinkage, if it is not visible and you are worried that it could be there, I think one easy thing is to put polypropylene fibers. Okay. They work, it's very easy, you don't have to keep checking for every crack, and mostly it works. This is what we have seen. And internationally, this seems to be a standard. 1 kilogram of short polypropylene fibers. That is good enough for plastic shrinkage cracking. There are admixtures also, but they may be more expensive than doing this. So you can evaluate what is the requirement.
Okay, sir. Okay.
Sir, sorry for interruption. It is not only for plastic shrinkage, it is for maybe thermal cracks.
Yeah,
it
I
occurs
agree.
in roof slab, it occurs generally maybe after a month, once we cast it.
Yeah.
So how to resolve the issue?
Yeah.
The cracks is there, the water is leaking.
Yeah.
Now we want to achieve monolithic concrete or whatever you called it.
Yeah.
How to integrate?
Yeah.
So what is the solution?
Yeah. First of all, your concrete is cracked, and that is when people think of IIT Madras. After the concrete is severely cracked and it's leaking like crazy, and
sorry,
somebody
sir.
says,
Actually, before thinking IIT
somebody
Madras,
usually calls Professor Manu Santhanam and say, it is leaking all over the place. Concrete is severely cracked. Can somebody help us? It is like saying, patient has died. Can IIT Madras, because of your reputation, bring it alive? Not going to happen.
No,
so I think we have to learn. We have to learn. And like Professor Manu said, you have to anticipate the type of cracking. What I tried to explain is there are different types of shrinkage. We have to understand that first. Thermal shrinkage means that there is probably not enough reinforcement to take care of the thermal stresses. So I've had arguments with a lot of structural engineers who do not understand, I will repeat, who do not understand thermal stresses. They just go by the codes. They do not understand initial temperature of concrete. They think it's a site issue. And they don't put enough reinforcement to handle thermal stresses.
Sir, sorry to interrupt one more time.
And restraint. See, shrinkage happens because there is a restraint. If it was free to move, concrete will not crack. Because of the restraint, like if you have a slab, the ground doesn't allow it to shrink. If you have a diaphragm wall, again, the length of the wall is preventing it from shrinking. And if you have periodic cracks every few meters, like Professor Manu said, then thermal shrinkage, if it's occurring in a few weeks, then we have to see how to bring down the temperature and if not, add enough reinforcement to handle those stresses.
Sorry to interrupt one more time.
Yeah.
Because in around 2,000 square feet slab, only around 100, 150 square feet, only this area have a lot of cracks.
Yeah.
So that is what the...
This is a slab, is it? This is a floor slab?
This is the roof slab.
Roof slab.
Around 5 inches thickness. Yeah. The reinforcement is almost uniform in all locations.
When did the crack occur? When did you see the cracks?
Around after a month. Once
After
concrete supplied, we compacted.
Yeah.
After 1 month, we find cracks.
Yeah.
Only around 200 square feet out of 2,000 square feet slab.
Yeah. So we'll have to look at it. I don't know. We have to look at all the
How to resolve that issue?
Yeah. You will have to come and get a consultancy project with us. We can certainly do it. Free advice is given, but not very often. Yeah.
Yeah, I'm having one request to the manufacturer RMC division. As a value engineering, it's a very clean point they have represented. So leave about the cementitious content. There it is fixed. When it comes to the aggregates, so fine and coarse aggregate, the manipulation, because fine aggregate, lot of materials like M sand is the major thing, replacement to the river sand, and right now the quarry dust. It's a big role playing because we can't identify what is M sand, what is quarry dust. So almost shapes, because whether the screening, the quality test, definitely it is happening, but as a sample, when comes to the mass production and mass procurement, these parameters are playing a very big role. And also when it comes to the competition among the agencies, they are playing with 100 rupees, 200 rupees by compromising some of the materials. Ultimately aspect, it is showing a lot of issues. That is a personal experience. We practically executed those kind of exercises. So this is a request. So give us very good product without compromising on the durability aspect, because it is not about only the strength. It has to solve for the life. Okay, over the period of time, definitely because of the carbonization, the porous, many things can happen into the structure. Definitely it has to be taken care. Leave out the current scenario. It has to be in a long-term condition. We have to consider. Thank you, sir. Thank you for the guidance and replies. It's a very thought of 2 hours. Thank you, sir.
Yeah. One of the advantages of RMC is you get a product. Clearly, there is an advantage if you get RMC from a good quality supplier. Lot of these problems of the cement not being right, the admixture, the aggregate should be resolved. Obviously, as a client, you should know what to check. So that is one of the things I said. You should make the cubes when the concrete is being discharged. Maybe if you're worried about porosity, do some tests. See, the more educated and prepared the receiver of the concrete is, better will be the supply. Yeah? So it is like food. Like concrete people always like to talk about food, like Professor Manu said. If you don't care about the taste of the food, the quality of the food, how long it has been from the kitchen to your table, you will get bad food. If you are particular about your food and will not repeat bad food, then you will always get good food. All concrete is not the same. All suppliers are not the same. So if we educate ourselves and we are strict, we understand, then we will get better concrete, is what I believe.
Hello. Sir, here. Sir, Inge.
Yeah, go ahead.
So I have a couple of questions. So one thing is, so some clients are very fond of that waterproofing admixture, like Dr. Fix-It or something. So what is the mechanism behind that? Is it really improving the waterproofing nature of the concrete? Or sometimes what's happening is, so even we are while using RMC,
Which product are you referring to?
Do you want to tell the product or not?
Dr. Fix-It. Dr. Fix-It.
Dr. Fix-It is the company name. Which is the name of the product?
Waterproofing admixture. They are selling.
Yeah, there are a lot of them.
Integral waterproofing, is it?
Yeah. Integral waterproofing admixture.
It depends on what it is. There are many being sold like that. Yeah.
So the thing is,
there are varying mechanisms. Some of them make the pores hydrophobic. There's several mechanisms. You can also have some products also apparently have a crystalline growth and so on.
But best is to check it. You make a cube and check the water permeability.
Yeah.
It's a very simple test. Very simple test. There is an IS standard. So instead of just assuming it works, just do a test on your concrete. In 28 days, you have results. Do a trial. We have to understand what they are doing.
So the thing, another thing that we are happening is, so when we are going for RMC, the client says, so when we go with the manufacturer of RMC, like we need this kind of waterproofing, they say, so we will not do this admixture at the plant. So what client expects is to get the RMC before concreting, they want to use the waterproofing admixture. Is it permissible? Is it going to be give effect on the water?
Again, we'll have to see why they are doing it. If it is plasticizing, then it doesn't make sense to add it after you mix. Okay. Right? Initially, when people were even using waterproofing admixtures in plastering, and the idea was when you need less water. So if it is that case, it doesn't make sense. So we have to ask this waterproofing compound that you're talking about, because there are many in the market. Yeah. So some may be okay. If it is safe, why not? But we have to understand how it is working.
Yeah, and sometimes some of these compounds can also reduce your work. If we looked at when you are putting multiple chemicals into your concrete, you need to be you were there yesterday. I said this once that if you are designing it and you have less than 3 months, you will not be able to deliver a good quality concrete. You need 3 months for a mix. It's not easy.
Cement and the minimum grade given for the exposure condition. So many time when we going with the RMC, they are saying that for M20 this is the minimum cement content, like that they are stipulating. Like
I understand what you're saying.
Yeah.
So the cement content and the grade that are specified are only the minimum. That they are not related there. That doesn't mean that for M40 I have to use only 360. It's not like that. Depends on the concrete strength development that I want. I need to design the concrete ascertain that my minimum maximum as per table 5 is satisfied. Okay. That's all.
So it is basically it is they are studying in a reverse order, like starting from exposure. Instead of that, they are starting from the strength they are studying. Is it going to be same? Like maybe in the future, is it going to be same table 5 or is
no?
there
In the
modification?
new IS 456, there will be methodologies given for you to do a proper durability design.
Okay.
That means you don't have to fall back on these numbers. Prescriptions will be available, but you will be given an opportunity to design the concrete for the required durability.
Thank you, sir.
Yeah.
Sir, even though I am from Concrete OEM, I have a couple of questions for both of you. It's not on behalf of Concrete OEM, behalf of all RMC industry. When can we be free from blaming for cracks for RMC industry?
Blaming?
On behalf of cracks.
I think never.
Never, huh?
How? You're in that business. I think that
Sir,
is part
we are
of
in
the
the
deal.
business,
Why will you expect to be not blamed?
See,
You will be blamed.
So it is written on our face.
Totally normal, sir.
Okay. Sir, one more thing, sir. Recently, we supplied a few temperature control concretes in all the 3 states. So what I have seen is the customer insisted for a core temperature less than 70 degrees, as your presentation says. I think, Manu sir, you mentioned 80 degrees in your presentation somewhere in the peak.
I didn't mention that temperature should be 80, but it
Okay.
went to 80 in
80.
some
Okay.
cases.
In that case.
Yeah. So even though we were being asked for a temperature less than 25, why they're still asking for gunny bag wrapping for the transit mixers? When we are complying to that, if we are giving 23.5 or 22 temperature at the time of placing, but still they are insisting that if your truck is not covered with hessian cloth, we will not approve it. What is the solution for that, sir? Each and every truck, right? They give us, I mean, when we have a pre-pour meeting, or they say that no, every truck has to be a hessian wrap.
See, putting the wet hessian cloth, I think, was a way to regulate the temperature in the
Correct,
drum.
sir. Correct, sir.
But if you're already taking care of it, it doesn't matter. It's,
So how
especially if the hessian cloth is dry, it doesn't make any sense at all.
Correct.
Yeah.
And the required placement temperature, we are far less
Yeah.
than that.
Yeah, that is
I
what
mean,
should
not
be
even
checked.
on the border.
Yeah.
We are having in pocket additional 2
Yeah.
degrees, 3 degrees. But
Yeah.
still, so I thought that this is the right place,
Yeah.
so we can convey.
No,
it.
as long as you can deliver at the required temperature and the client can check and measure, should be fine.
Right,
How you deliver is more of your problem than anybody else's
Correct,
problem.
sir. Correct, sir.
Yeah.
That I agree, sir. But I thought just let us
Yeah.
talk about it so that.
Yeah,
it will
I've
be very
also
clear.
heard this before,
Okay.
but I think it's not necessary.
Thank you, sir.
I
Thank you
think
very
it's
much.
not necessary. I don't see any purpose. As long as you are able to deliver, it's fine. But probably this came from RMC suppliers.
Correct.
You people are the ones to blame.
That's what I'm telling you. sir.
Somebody,
When can we
somebody
be
would have
free
come up with a
from these
marketing
blames?
trick. Somebody would have come up with a marketing trick saying that all our RMC trucks have Hessian cloth. Therefore, we are better.
Oh,
that is what somebody must have started this story.
Okay.
So,
but end of the day, we need to see the product performance.
Yeah, product,
right,
always.
So
always.
that is what we are keen about, and we want to take into the market that once we promise, we compel to that.
Yeah.
So, and we are also doing that. But we need to change the strategy of people thinking that they still insist
I
on.
think just to give a thought to the other side,
Exactly.
I think the Hessian cloth, wet Hessian on the surface is a mechanism to protect and to ensure that you are able to deliver without too much increase in temperature in the transit time. But if, as long as you're able to maintain it, it's fine. But,
Sir, whereas we are
but
also...
it's like a provision that they put into the specs saying that, okay, in case there's an increase in temperature during transit, this wet Hessian should be able to regulate that and ensure that that doesn't happen. So it's more of a protective suggestion.
Correct, sir. Sir, whereas when we do the laboratory trials and we measure the same retention until 3 hours, we don't have any sort of precautions for the trial mix, right? Even though we measure, in a similar way, we do the plant trial as well as a laboratory trial. We induce ice flakes, chilled water and everything, right? So even they use some retarders also for the longer retention hours, for 3 hours, for the same temperature of concrete. So we are following all those things, sir. But still, I just thought it is the right place to so that people understand the real need of it. If there is no, addition of ice, or if it is a longer journey, then we can understand. But when you do the trials for 3 hours without those things, then it should be realistically also applicable to that, and ensure that we are with the, less than the prescribed placement temperatures. So this is one, sir. So there is one more question. We have recently supplied for one of the project in another state, footing as well as column. Raft, it's an individual isolated footings. So in the column, we have got very good compressive strength results at 7 days as well as 28 days. Whereas due to the some other workmanship issues where the rebound hammer of the column has been complied with the requirements and UPV test has been failed. So how can an RMC vendor can be blamed on this? Can you please explain?
See, each case is different. One thing is you need to understand the rebound is not an indicator of the strength.
That's why it's a hardness test. Totally, I understand,
it is
sir.
only an indicator of the surface hardness and surface
sir.
quality.
Sir, cubes as well as 7 days and 28 days complied. There's nothing to do with
ultrasonic pulse velocity is an indicator of the overall integrity of your concrete.
Right,
Again, it is not it's not related to the strength.
Okay.
It is a measure of the overall integrity. Now, if the UPV is getting failed, it's possible that there are pockets of poor compaction inside the structure.
Agreed, sir. So for that, how can an RMC vendor can be blamed?
That, I don't know what discussions took place that day between RMC and the
Thank you, sir. Thank you. So please, guys, other guys, you can ask your question. Thank you, sir.
Good evening, sir. Myself, Mohammad Ashik. We are from an urban development company. Actually, we are facing more clients than regular engineers because we are facing non-technical clients most of all. So they are feel like RMC is non-reliable than SMC. SMC is more reliable. They are feeling like. How can we handle this type of situation, sir? Actually.
But these are the buyers of your property?
Yes, sir.
They are insisting?
Yes, sir. They are insisting RMC is more not reliable than SMC. How should we handle these types of...
best thing is to talk to them. No, sometimes you have to educate the final client also.
Even
it will be difficult, but you have to tell them it is proper. Maybe go for a reliable brand. If the client is very important, maybe if they are buying 10 flats from you, take them to the RMC plant. Jagannath will show you the computers which are there, everything is controlled, and maybe it is possible. See, what has happened is because of these cracking issues and quality issues, RMC is getting a bad name, unfortunately. Unfortunately, so we have to face it. It is a problem we have created. Everything. Maybe some RMC did some bad job and therefore everybody is getting blamed. So
Even
this
though
is...
we technically are explaining, they are not...
Yeah, I understand. Yeah.
Because we're doing 15 projects at a time. So yes, RMC is more comfortable for us.
But generally, does the house owner, whoever is buying the flat, will ask you to put RMC or this thing? Okay. And these are knowledgeable clients or not? Some.
Mostly not.
But it's very key. I would have expected that they don't care. They will see what is the carpet area and they will see the color of the wall. But if somebody is saying how you should concrete it, I think it's good. Please send them here. Let's talk to them to see why, what is their concern. So maybe see, those kind of people probably we should talk to.
Yes, sir.
Then next time what you should do is you organize a seminar like this for your end clients. You bring the end clients all together and let them all sit, all those who are going to buy from you, and somebody can tell them what is concrete, how it should be done, what should be checked. Instead of telling them, don't tell me whether I should use RMC or site mix, you come and see the cube test. Yeah?
Actually,
So maybe let's take advantage of this need for knowledge and their need to participate in the project. Instead of blaming them, saying they are non-technical, they should leave it to us. Make them participate. You come and see the cube test. Tell them that M30 means there should be at least 35 MPa of strength. Maybe they will get more confidence. Yeah?
Actually, like you, I'm also curious about how they learned these things from.
Yeah, that is very good.
Yeah,
So I think this is good.
Simply said, I saw it on social media.
Yeah.
I scroll to YouTube.
No, that's good. That's good. Maybe they saw one of our videos. But no, but it's good. I am very happy that the end client is aware, because that is the only way that the sector can go up, is when the end client starts asking questions. So we should turn it around. Don't think of it as a problem. Maybe it can be a good solution. Maybe they will come to you only because you are doing higher quality concreting than some other builder. So you can say that I will be transparent. I will show you all my quality control records. Maybe you can leverage it instead of thinking it is a problem.
I think it's also linked to the question that was asked previously. How do we improve the quality of structures that are built in unregulated conditions? Again, it's mainly knowledge dissemination. One set of videos that was earlier prepared, I think 3 years back, there was a set of videos called Technology for Home. And this is basically intended for the individual buyer who has no idea about cement, concrete, and all those kinds of things. Those are videos that can really spread the word about good quality materials, good quality concrete, and so on. I think you can refer your clients to also see that. And as Professor Gettu said, it's important that dissemination happens, so that it's very nice that they are able to make a distinction between site mix concrete and ready mix concrete. Yeah. But yeah, you have better understanding of the process, and you should be able to convince with the right kind of dissemination.
But they are just taking our lives out of our body. That's what is basic. Okay, sir. Thank you. Thank you for your time.
Hello, sir. Good evening, sir. Good evening, concrete superheroes. Thank you so much, sir. I'm here. Sir, I have 2 questions, sir. Actually, sir, I'm here.
Oh, here. Sorry.
Yeah. Thank you, sir. Sir, actually, why slag will not reduce the thermal cracks compared with fly ash? Could you please explain?
No, see, if you compare the relative reactivities of these materials, cement is most reactive, so most heat. Fly ash is much less reactive than cement, so it reacts slowly, so it liberates heat very slowly.
So I can take like this. Actually, GGBS is partially hydraulic material.
Yeah, GGBS is a latent hydraulic material, so it is able to liberate. It reacts much faster than fly ash.
Okay.
And even if you substitute 50% of cement by slag, it takes only about 3 to 5 days when it catches up with OPC concrete. Okay. So, general thumb rule is for every 100 kilogram of cement, your temperature of concrete goes up by 12 degrees Celsius.
Achha.
For every 100 kilogram of cement.
Okay.
Now, if you have 100 kilograms of PSC, slag cement, your temperature rise may be about 10 degrees Celsius. Okay. If you have PPC, or if you're even reducing your, increasing your fly ash to about 40%, right?
Okay. Okay.
The upper limit is 35, but you can also go up to 40. In which case, your temperature rise for 100 kilograms of cementitious material will be only 7 degrees Celsius.
Okay. So fly ash is the best material for lowering temperature of mass concrete.
Yes, sir. Fortunately, nowadays we are using we are start using composite cements. So, what about your opinion on that?
Again, composite cements are also very good for low heat of hydration concrete. Absolutely.
Okay.
Definitely. I'd certainly recommend using composite cements for low heat of hydration. For mass concrete, foundation work, composite cement will be perfect.
Fine. Yes. Sir, and one more thing. Sir, as you said, excess paste, mixed paste will create some kind of plastic shrinkage. So, but as per standard, we are using, SEC, below 125 micron, we are using 400 kg per cubic meter to up to we are going 600 kg per cubic meter. So, obviously, I couldn't understand that.
No, yeah, you're right. What you're saying is perfectly right. In SEC, we have a very high paste content.
Yeah.
So it is definitely going to have greater propensity to crack.
Okay.
More propensity. Higher the aggregate, lesser the chance of cracking.
Yeah.
Higher the paste, more the chance of cracking.
Yeah, I agree with you, sir. But what you said, the PPT. So, in SEC, we can reduce the plastic shrinkage crack and thermal cracks. So I couldn't take the.
No. This was the example I showed you was the application of self-compacting concrete for a 1.5 meter thick raft. So here we had to do all the precautions necessary, keeping the temperature low so thermal cracking could be avoided, keeping the surface perfectly planned so that if we see cracks appearing, we have people floating. And those kinds of precautions were taken because of which there was no cracking. Right? So again, this goes back to the same question that somebody was raising earlier. PPC and PSC show more plastic shrinkage cracking. But that doesn't mean we should stop using them. We have to only use them. In fact, we should stop using plain OPC, in my opinion. Only use blended cement as far as possible. But go ahead with the precautions to ensure that cracking won't happen.
Yes, sir. Actually, people are very inspiration for us. Actually, I'm very happy for here. Thank you so much, sir. Manu sir, especially thank you. Okay, sir. Thank you.
Hi, sir. I think there's a gentleman here who's been trying to ask a question for last 15 minutes. Let's do that.
Yes, sir. Sir, this is Bhupati from Unicore Construction.
Yeah, we'll take one more question after this and stop because I think the food is getting cold and we said food is like concrete. We cannot.
Sure, sir. Yeah. Sir, in one of our project we used SEC for aluminium formwork, and since it is a SEC, we didn't use any external vibration for it. Actually, we have done it with malleting and rubber malleting we have done for the shutter. But even then, we could able to see a lot of potholes or small this one coming up. How to avoid it, or is it how it is to be properly compacted?
Yeah, I'll leave that question to Professor Gettu because he's perhaps got the first SEC structure in India, which is his own house.
Okay.
One of the important things is the demolding agent. See, a lot of times they use this burnt diesel and whatever waste oil, engine oil is there. So the formwork oil release agent is also important. So the fact that you have bubbles means that maybe your demolding agent is not good enough. Maybe you can check if that can be done. The the formwork should be clean, should be properly oiled. Then the air bubbles can reduce. But what you're doing is correct. Malleting, little bit of vibration is the best we can do. But I think please check your demolding agent if something can be better. What they say is demolding agents based on vegetable oils are better than those from mineral oils. And waste engine oil, all these things is bad. It retains the air. Basically, this is not a problem of the concrete. It is that air bubbles are not being released. It is holding on because of surface tension. The air bubble is there.
Okay,
So nothing to worry about except for aesthetics. But you can work on the demolding agent.
Demolding agents. Thank you, sir.
Yeah.
Sir, last one more.
Last question.
Sir, any admixture specially designed to reduce the carbon footprint?
Admixture for carbon footprint. Use fly ash, use slag. Yeah. Use fly ash, use slag. That would be good. And treated water. make your structure more durable?
That and all coming under mineral admixtures, sir. Especially we are asking for the admixtures.
Yeah, for carbon footprint.
Admixture chemicals. Yes,
chemical
yes.
admixtures.
Yes,
chemical
sir.
admixtures.
Yeah.
Yeah.
Obviously, all your concrete should be made with super plasticizers. Reduce the usage of water in your concrete.
Yes.
Reduce usage of water, reduce water cement ratio, increase your durability.
Exactly, sir. Correct. Thank you, sir. Thank you.
Yeah.
Hi, sir.
I'm very sorry, my dear friends, concluding the question sections because of shortage of time and our food is getting cold. And thank you very much, sir, having such a useful interaction with our audience. I am confident that it was very interactive and very useful for you all. Am I correct? It was useful, na? Correct. So we come to the end of the session. We would like to take a moment to express our gratitude and our gratitude to our esteemed speakers. So now I invite our dear Managing Director, Mr. Tagore, and Mr. Jayesh, our Vice President, to come forward and present a memento as a token of our love, appreciation, and gratitude. May I welcome Mr. Tagore and Mr. Jayesh to our stage. Sir, come. Give me a big clap. Please give a big applause. May I request, sir, please? Sir, please.